Math, 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 math.
Oh, hey guys, how's it going? Didn't even notice you there. A little awkward. Okay, so in this video we're going to look at rates of change, and we're going to look at our rule y2 minus y1 and x2 minus x1. And at the end of the video, there'll be a link to click on some examples, alright? So give me a minute, we'll get started. Beard maintenance. So to find the rate of change of a function, you need two distinct points and find the difference between them. So we're going to use our rule y is equal to ax plus b again, and we're going to do the change in y over the change in x, except now we're going to be more specific. When we say the change in y over the change in x, what we mean is y2 minus y1 over x2 minus x1. And all that means is that we're picking two y coordinates and two x coordinates and subtracting them, all right? In this case, we decided 0 was going to be our y2 and negative 3 was going to be our y1. You could have done the reverse, doesn't matter, okay? You just pick two y coordinates. But whatever you pick as your y2, its corresponding x coordinate has to be your x2. So in this case, 4 is our x2 and 0 is our x1. Now we just take those coordinates and plug them into our equation. We have a is equal to 0 minus negative 3. A negative and a negative make a positive, and we have 4 minus 0. So for our a, we have a is equal to 3 over 4. But now we have to figure out what b is. So when x is 0, what is y? So we look at our Cartesian plane, we go to 0, and we look up or down our y-axis, and we see where the line cuts through the y-axis. And in our case, it cuts through at negative 3. Bam, right there. So b is equal to negative 3. So now if we put the entire equation together, we are going to have y is equal to 3 over 4x minus 3. We're going to go on to another one now. So now we need to figure out how to do the rate of change with the table. So here's our table. Now we use y2 minus y1 and x2 minus x1 when we see that our table isn't going up by the same amount. Usually our tables go up by 20, 40, 60, or our x column goes up by 1, 2, 3. That's not happening here. Okay? So we're going to start the same way. We have our step 1, which is y is equal to ax plus b. We move on to our step 2, which is the change in y over the change in x, or now, like we said, y2 minus y1 over x2 minus x1. So we pick a coordinate in our y column. In this case, I decided 20 to be my y2 and 26 to be my y1. If I pick 20 as my y2, then I have to pick 5 as my x2, and I have to pick 7 as my x1 because they are corresponding. We continue with our equation, so now we'll have 20 minus 26 and 5 minus 7, and you can see that that's going to give us 3 because we end up with negative 6 over negative 2, a negative and a negative make a positive, we have positive 3. The important thing is we have to make sure that we take our coordinates together. 5 and 20 go together. That's my y2, so 5 has to be my x2. 26 is my y1, so 7 has to be my x1. And you can see right here how our coordinates go. We have y2 is 20, x2 is 5. y1 is 26, x1 is 7. Now we still need to figure out, though, what b is. So for step 3, we have half our equation there. We have y is equal to 3x now plus b. The way we do that is we pick two corresponding coordinates and just plug them into the equation. Any two. So in this case, let's just pick 10 and 35. So we plug those in. So now we have 35 is equal to 3 times 10 plus b. And now we just solve this algebraically. So 3 times 10 is 30. We now have 35 is equal to 30 plus b. We have to get rid of that 30 now. The way we do that is we subtract 30 on both sides. 30 minus 30 gives us 0. They cancel each other out, and we're left with b is equal to 5. And again, now we can put this all together into our rule, and we end up with y is equal to 3x plus 5. We're going to go do some examples now, all right?